Let's take a look at our 10th problem type. This is finding the price elasticity of demand. Now let me write down the formula we'll be using. This is eta, and it's equal to P divided by X over our derivative. And we're going to be finding the absolute value of eta and set it equal to 1. And use this to find our critical values. Now in this problem, P is equal to 500 minus 2x. I need a derivative, so derivative of P with respect to x. 500 drops away, and the derivative is just negative 2. So then, I want to find the absolute value of eta. So we got the absolute value, P over x. So I'm going to have 500 minus 2x over x, all over our derivative, which is negative 2, equal to 1. Well, if we have a single fraction up here and then a denominator here, you can take this x and put it right next to the negative 2. So this becomes the absolute value of 500 minus 2x over negative 2x equals to 1. Now, maybe I ought to continue it here. If you remember this from college algebra, when you got the absolute value equal to a number, you drop the absolute value, set it equal to the positive the other side. So we got 500 minus 2x over negative 2x is equal to a positive 1. And you drop the absolute value, and you set it equal to negative the other side. Now we're going to solve each one of these. Here, if I multiply both sides by negative 2x, I get 500 minus 2x equals negative 2x. And get all the x's on one side, and I get negative 2x plus 2x. Combine together like terms, and we get 500 equals 0. This doesn't go anywhere. You'll oftentimes find that one of your answers is garbage, and you can just ignore it. Now in this other one, if I multiply both sides by negative 2x, we get 500 minus 2x equals negative 1 times negative 2x is a positive 2x. Get everything with an x on one side, so I'll take negative 2x to the right side, sorry. And that becomes a positive 2x. 2x plus 2x gives us 4x. I think that's 125. Divide both sides by 4. Yeah. It's too late at night. I better go to bed. Okay, that's our critical value. So we're going to build an interval. Now, over here I'll put x equals 0, and over here is positive infinity, though in practice we know we can't go that high. So I'm going to pick a test case. And I'll pick, I don't know, x equals 1. Something between 0 and 125. Something greater than 125 that's fairly easy to work with. 200 maybe. And we want to plug these in to the absolute value of eta. Plug this in right here. And we'll see why once we get our values. So we got the absolute value of 500 minus 2 times 1 over negative 2 times 1. In here we got the absolute value of 500 minus 2 times 200 over negative 2 times 200. Okay. This is 2 times 1 is 2. 500 minus 2 is 498. Negative 2 times 1 is negative 2. And I don't want to think that hard tonight. 498 divided by 2. 249. Then the absolute value of it gives you a positive 249. Well, let's do this one here. 2 times 200 is 400. 500 minus 400 is 100. Over negative 400. Well, the absolute value makes it positive, and top and bottom both divisible by 100, so that gives us 1/4. Now our conditions on this are that if the absolute value of eta is greater than 1, then the demand is inelastic. So this is greater than 1, so this is inelastic. Now the other criteria is if the I wrote that down wrong. I said better go to bed. If the absolute value of eta is greater than 1, then it's elastic. Sorry. And the demand is inelastic if the absolute value of eta is less than 1. This is less than 1, so this is inelastic. Okay, so our intervals of elasticity, it's elastic from 0 to 125, and inelastic from 125 to infinity. Now we know 0 doesn't make any sense, but again, this is parentheses, so it doesn't include it. And we know infinity doesn't make any sense, but we'll go with these intervals here. Now the one we're trying to find, it's wondering when x is equal to 50. Well, 50 is between 0 and 125, which is elastic. Now if we wanted to find eta, what we can do is plug this in for our x. So we got 500 minus 2 times 50 over negative 2 times 50. 2 times 50 is 100. That gives me 400 on top, and down below that's negative 100, which gives me 4. So that would be our value given that. And I think that's everything they were asking for. Yeah. Now let me double check what I wrote down there, just to make sure I remember it correctly. So let me see. For a given price, the demand is elastic if absolute value of eta is greater than 1. So elastic, yeah. And then demand is inelastic if n is or absolute value of eta is less than 1. So inelastic. Okay, that's right. I just wanted to double check that with the book. Sometimes my memory isn't what it should be, but that'd be that problem.